So this one is similar to number one, but I've got angles involved this time. So as soon as I see angles involved, I'm thinking that it's probably a SOHCAHTOA problem. So I'm going to write that down up here. Remember, if I have angles involved, it's typically that. If I just have sides, then it's typically a Pythagorean theorem question. One of the first things I want to do is identify my right triangles. So there is a right triangle right there in blue. And then there is a right triangle right there in green. So I have those right triangles right there. Okay, now, how are they going to help me? So the blue triangle will give me that height right there. I'll call it A. The green triangle will give me that height right there. I'll call it B. All right, and then what I'm going to do is I'm going to take B and I'm going to subtract A from it, and it's going to give me X. And again, with this, I'm just trying to take the right triangles and formulate some sort of plan so that I can figure out what I'm going to do with that specific situation before I even start. Okay, so now it's got angles, so I'm going to go ahead and set up a SOHCAHTOA problem. So for this blue triangle, I'm going to go hypotenuse over there, that's where it is. I'm going to go opposite over here, which is going to make the 87 the adjacent. And then I'll deal with the blue triangle first. All right, so what am I going to use for the blue triangle? Well, I want to know this. So I'm going to use the opposite, and I'm going to use the adjacent. That is a tangent problem. So for the blue triangle, I'm going to get tangent. And then I fill in what I know. I know the adjacent is 87. I know the angle is 25. I do not know the opposite side. Since I know the angle, I'm going to put it over 1. I'm going to get tangent 25. It's going to give me 0.466. When I cross multiply, I'm going to get x equals 40.568. So that's going to give me and that was my A side. So that's A. Now to get B, I got to use the green triangle. I got to be careful here with the green triangle. So the hypotenuse of the green triangle is over here. The opposite of the green triangle is over here. And it's important to remember that you're, ignoring the blue stuff for the green triangle. And that would make the adjacent the 87. So the adjacent is the same in both of these triangles. That is not always the case. It's the case more often than not, though. So for the green triangle, I want to know the opposite. I know the adjacent. So it's going to be a tangent problem again. Now, another thing, does it have to be the exact same for both of them? No, but I will say that it's the same more often than it's not the same. I have to really think about a problem in order to make it different for the different triangles. So I know that's 87, it's the adjacent. I know the angle is 40. Let me try to do some lines with that. Yeah, 40. And then I don't know the opposite. So again, I know the angle, put it over 1. And I'm going to take my calculator, tangent of 40. It's going to give me 0.839. 0.839, blah, blah, blah. And then I will cross multiply, and I'll get x equals 70.001. That's not 73.001. 73.001. And then, like my plan in the beginning, not middle, I'm going to subtract those two. So I'm going to get this lighter one minus. So it's not that. That minus that one is 32.432. Okay, and it says nearest tenth of a foot. So rounding the 4, using the 3, 32.4. Good news is these all work very similar. The bad news is they are a little bit of work, and you have to make sure you're thinking about them as you go. So you're not going to subtract every single one.